Good day. I'm going to discuss the electricity. So this is the first module. Number one is introduction to building utilities, electricity, the nature and forms of electricity. Electricity plays an important role in man's daily life. We use this in operating our numerous devices and appliances such as lights, ranges, freezers, fans, and many more. Machineries and equipment in many industries and factories are operated by electricity. While it is true that electricity is one of our primary needs because of the numerous things it can do for man's convenience, the improper use of it may be risky to man, for it may result to shock or fire. Electricity refers to a stream of electrons flowing along a conductor. The flow of such electrons results into such effects as heat, light, sound, coldness, pressure, magnetism, and video. The discovery of electricity by ancient Greeks in 600 BC was only accidental. An English physicist named William Gilbert, the year is 1540 to 1603, he became interested in the study of the strange behavior of amber. He went deeper into his observations by trying numerous substances aside from amber. He noticed that the substances on his hand, when rubbed with a piece of cloth, also attracted bits of paper and straw. The findings of Gilbert motivated him to publish his book, The Magnetic, in 1600. He made use of such items as electric attraction and electric force, which are still used and recognized today. It is for this reason that he was given the honor as the father of electricity. Electricity, the will cover the concept of basic electricity being used by electrical engineers. Terms or terminologies and concepts will be discussed. A building can be considered as a series of individual interconnected components whose function is to provide human comfort through its various utility system. Science thus believed that the greatest invention man had discovered is electricity. Without it, civilized world cannot flourish. Electricity is the most prevalent form of energy in a modern building. It supplies not only electric outlet and electric lighting, but also the motive power for ventilation, heating and cooling equipment, traction power for elevators and material transport, and power for all signal and communications equipment. An electric power failure can paralyze a facility. If properly designed, the facility will return to partial functioning by virtue of emergency equipment that will furnish some part of the facility's electricity needs for a limited time. Electric charge. As early as 600 BC, the ancient Greeks were already aware of the manifestation of the presence of electrical energy. Thales of Miletus, for instance, noted that amber rubbed with wool acquired the property of attracting light objects. Today, in describing what was considered then as an unusual phenomenon, we say that amber is electrified, possesses electric charge, or is electrically charged. The terms are derived from the Greek word electron, which means amber. There should be nothing unfamiliar about these concepts to the college students. The hard rubber rod, plastic ruler, is first rubbed with fur, after which it is brought into contact with tiny pieces of paper. Placed in a container, the pieces of paper cling to the rod for a few seconds and then fall off. The conclusion from this simple experiment are clear and unmistakable. They lead definitely and logically to the concepts of two kinds of electric charges. The charge possessed by hard rubber after being rubbed with fur is called a negative charge, and that possessed by the paper is called positive charge. They likewise demonstrate clearly that like charges repel each other, while unlike charges attract each other. The implication of this is clear. Therefore, since the bodies are not charged initially, that electric charges are neither generated nor created, but are simply transferred from one body to another. Stated in another way, the process of acquiring the electric charge consists simply of transferring something from one body to another, so that one body has an excess and the other a deficiency of that something. It was not until the end of the 19th century that this something was found to consist of very small light piece of negative electricity. We know this something today as electrons. Electricity is a form of energy generated by friction, induction, chemical change, having magnetic chemical and radiant effect. Electricity is electrons in motion. The father of electricity is William Gilbert. Electricity is a property of the basic particle of matter. Like an atom, it has protons, electrons, and neutrons. Electrons, negatively charged particle of an atom. Proton, positively charged particle of an atom. It weighs 1,850 times the electron. Electron theory of matter. The electron theory of matter explains the following. First, that matter in this earth is made up of molecules which are considered the smallest particle of any substance. Second, that the molecules mentioned above are made up of atoms. Third, that an atom, which is the smallest particle of a molecule, is further scrutinized. Will be found to have electrons which carry a negative charge, protons which carry the positive charge, and neutrons which possess no charge at all. Ordinarily, the atoms in any substance have the same number of electrons and protons. If the number of negative charges is equal to the number of positive charges in an atom, the atom is said to be electrically balanced. Fourth, that the electron of an atom in any substance may be able to transfer to another atom of another substance. The gain and loss of one or more electrons may result into having a positive or a negative charge. An atom with positive or negative charges is referred to as ion. The presence of electron in all things could be defined. It is therefore a fact that electricity is present within the person and in his surrounding. All matters are made of molecules. Molecules are made of atoms. Atoms contain neutrons, electrons, protons. Neutron is neutral, neither positively nor negatively charged. Electron of an atom of any substance could be transformed into another atom. A property of basic particle of matter like atom, it has proton, electron, and neutron. The atomic theory. The word atom is derived from the Greek word atomos, which means invisible. It is hardly necessary to point out that the term has become completely misleading and inappropriate. It is now common knowledge that there exist many dramatic and elaborate methods of dividing. Splitting is the actual word used by scientists, physicists, and electrical engineers. The atom, either singly or in groups. The most spectacular of these means is the disruption of an atomic nucleus. In the process of nuclear fission, the continuing and painstaking research of the last 6 decades or so on has led to the conclusion that atoms constitute the building blocks of matter, and that all atoms are composed of subatomic particles arranged in the same general way. These subatomic particles are of three different kinds: the negatively charged electron, the positively charged proton, and the neutral neutron. The protons and neutrons form a closely packed group called nucleus, which, due to protons, has a net positive charge. Danish physicist Niels Bohr in 1913 still suffices to serve the purpose of enlightening the students regarding the behavior of matter. The nature of electricity, Bohr's atomic model. The electrons are pictured as whirling about the nucleus in circular or elliptical orbit. Although there is now wealth of material showing that this model is not entirely correct, it is still useful in visualizing the structure of the atom. As stated earlier, the Bohr atom nucleus corresponds to the Sun. The electrons correspond to the planet revolving around the Sun, and the electrical force to the force of attraction between the Sun and its planet. Although we have mentioned briefly the existing similarities between the atomic system and the solar system, there remain many aspects of the atomic system which cannot be predicted by analogy with solar system, and which cannot be explained in terms of classical mechanics. Two general classes of electricity: dynamic electricity, or it is also called electrodynamic, flows through a substance over its surface in the form of electric current. Second is the static electricity, or it is called electrostatic. The kind of electricity which is produced by friction or by potential differences is referred to as static electricity or electricity at rest. Example: lightning storm. Benjamin Franklin experimented of the kite, and lightning rod was later on developed. Electric current. Electricity flow in electric circuit. So when we say electric circuit, this is actually in a form of wires. It is expressed in amperes. Electricity flowing in a conductor is called current or amperage, and is abbreviated AMP or AMPS, or simply A. When current is used in an equation, it is usually represented by the letter I or small letter I. two kinds of electric current and is classified as direct current and alternating current, abbreviated as DC and AC. Whenever the flow of electric current takes place at a constant time rate, practically unvarying and in the same direction around the circuit, it is called DC. The DC voltage of 1.5 volt positive polarity and 1 volt negative polarity. And if whenever the flow of current is periodically varying in time and in direction, as indicated by the symmetrically positive and negative loops of sine waves, it is called alternating current. The distance along the time axis spanned by positive and negative AC loop is called one cycle. The number of such cycles occurring in 1 second is known as the frequency of the AC current. Modern AC systems operates at the frequency of 60 cycles per second or 60 hertz. It is also abbreviated H, which means hertz. This means that current at 60 hertz is delivered to the consumer. The AC circuit differ from DC circuits in a number of important respects, and since normal current supply is 60 hertz AC, it is important to understand AC terminology and usage. Instead of resistance, the corresponding parameter in alternating current circuit is impedance, which is also measured in ohms or the Ohm's law. Ohm's law is I equals to V divided by Z, where Z is the symbol of impedance. Electric power generation, direct current, also abbreviated as DC, with respect to generation of large amounts of power, leaving the battery and the DC generator as source of the DC current. The battery is still the only major direct source of direct current. There are some special type of generator that produce direct current directly, but their use to date has been extremely limited. The practical applications of DC in buildings are for elevator power and to a lesser extent standby power for computers and other critical loads. Second, alternating current, also abbreviated as AC, the process by which electricity is produced is based on the fundamental discovery in 1831 by Michael Faraday of the principle of electromagnetic induction. This principle states that when an electrical conductor is moved in a magnetic field, a voltage is induced in it. The direction of movement determines the polarity of the induced voltage. If the conductor is formed into a coil and rotated in the magnetic field, a voltage of alternating polarity is produced. That is alternating current. It does not matter whether the conductor or the magnet moves. The motion of the conductor and the field with respect to each other produces the voltage as noted above. It is 60 Hz in the normal generator frequency. Alternating current or voltage is a circuit operating at increased voltage has a lower power loss. Lower voltage drop and considered more economical to construct. The AC current goes through one positive loop and one negative loop to form one complete cycle, which is continuously repeated. The number of times this cycle of plus and minus loop occur per second is called the frequency of alternating current expressed in cycles per second. Actually referred to as Hertz or abbreviated as capital H and small letter z. The frequency of a direct current is obviously 0 Hertz since the voltage is constantly and never changes its polarity. Resistance. Electric wiring installation is also impeded or resisted by the wire, transformer, and other devices and is referred to as impedance, which is the electrical term for friction in AC, electricity. In a direct current circuit, this factor is called resistance. However, both express their unit is ohms. Direct circuit, the current is proportional to the voltage and inversely proportional to the circuit resistance or load. Thus, the higher the voltage, the larger the current. The higher the resistance, the lower the current. This relationship is expressed by the following equation, known as the Ohm's law, where I is the current expressed in ampere, V is the voltage expressed in volts, R is the resistance expressed in ohms. Formulas: current equals to I equals to voltage, and then you divide it by R, which is the resistance. So you can also transpose this. If you would like to look for voltage, voltage is equivalent to I times R. You can once again utilize this formula in solving for the resistance. Resistance is equivalent to V divided by I. The unit of electric resistance is ohm. Ohm is the flow of current in an electric circuit. It is resisted by resistance, which is the electrical term for friction. In a DC circuit, this unit is called resistance and is abbreviated R. In an AC circuit, it is called impedance and is abbreviated as capital letter Z. The unit of the measurement is the ohm. It is interesting to note that the scientific convention of naming units after persons whose work is closely related to the field is followed here also. Thus, the units ampere, volt, and ohm are derived from Andre ampere, Alessandro volta, and George ohm. Factor which influence the resistance of a conductor, composition of a conductor. The mineral composition of a conductor is an essential factor in determining a good conductor. Length of a conductor, the longer the wire, the greater the resistance. Cross-sectional area of the conductor, the bigger the cross-sectional area of the wire, the lower its resistance. Temperature, metal offers high resistance to high temperature. Electric circuit, electric path composed of conductors and conducting electricity devices joined together through which an electric current flows when the path is complete and the electromotive force is applied. Electric current, the rate of flow of electron force in a conductor. Electricity flows in a conductor is called current. A current will only flow if a circuit is formed comprising a complete loop and contains all the required components, such as one is source of voltage, number two is a closed loop of wiring, number three an electric load, number four is a means of opening and closing the circuit called switch. Three essential aspects of electric current. One is electromotive force. So this one has the unit of voltage. So sometimes it is abbreviated as EMF. An electrical pressure that causes the movement of electron to flow from one point of a conductor to another. Number two, current flow refers to flow of electron from point of origin, which has an excess of electrons, to a point of less electrons. That is why it is said that the current flows from negative to positively charged. Resistance is the opposition to the flow of current. The ability to resist current flow by substance is called insulator. Every conducting material has resistance but of minimal effect. Electromotive force or EMF the force which causes or tend to cause the movement of electricity in a conductor. An electric circuit is considered complete because it has the following part. Number one, source. Any device where current starts to flow is called EMF source, which refers to the battery cell, generators, storage cell, and transmission power lines. This causes the current to flow. Then second, path. All parts of the circuit where electricity passes through, they are the conductors, or in short, these are the wires, which link all parts in the circuit. Third, load. Any devices that uses electricity, such as television, radio, lamp. So when we say lamp, we are referring to the fluorescent or an incandescent light bulbs, etc. Also known as current consuming devices. Means of control. They function in two ways, either to close and open the circuit. A good example here are switches and circuit breakers. Electric circuit, the complete path traversed by electric current. It is the entire house wiring installation. Closed circuit, also known as complete circuit, connected to form a continuous path from the source of current back to the same point. So in say closed circuit, sometimes we just simplify the term as on. Open circuit, also known as broken or incomplete circuit. Conducting elements are disconnected as to prevent the flow of electricity. So in simplest layman's term, we just simply turn it off. Short circuit, a condition resulting from bridging any part at a very low resistance. Power and energy. It is important, indeed imperative, that the distinction between power and energy be clearly understood, since to all, frequently, the term are incorrectly used interchangeably. Energy is the technical term for more common expression. Work. Power is the rate at which the energy is used. In terms of power, energy is the product of power and time. That is, energy or work is equivalent to power multiplied by time. Power and energy, work is power, while energy is fuel. Energy or work is equivalent to power, then multiply it by time. In practical terms, energy is synonymous with fuel and therefore also cost. Thus, energy can be expressed as barrels in tons of oil, cubic feet, or in terms of cubic meters of gas, tons of coal, kilowatt hours of electricity usage and the operating cost. The concept of energy efficiency of structures can be stated in terms of annual usage of oil, gas, and electricity, or alternatively in terms of total fuel cost. In technical terms, energy is expressed in units of BTU, or British Thermal Unit, which is in calories, foot-pounds, or in terms of joules, and kilowatt hours. In terms of fuel, 1 kilowatt hour, abbreviated as kWh, of energy is roughly equal to 0.5 pound of coal. Or it is also expressed in 0.07 gallons of oil, or 7.7 cubic feet of natural gas, or in terms of 8,200 gallons of dam water. Energy is synonymous with fuel. Energy can be expressed as gallons, liters, bottles of tons of oil or coal, kilowatt hours or consumed electricity, and cost of operation. In technical terms, energy is expressed in units of BTU, or British Thermal Unit, which is in calories, foot-pound, or joules, and kilowatt hours. Power is the rate at which energy is used, or alternatively, the rate at which work is done. Since energy and work are synonymous, the term power implies continuity, that is, the use of energy at a particular rate over a given, generally considerable span of time. The concept of power necessarily involves the factor of time, since it is the rate at which work is done. Thus, multiplying power by time yields energy. Typical units of power in the English system are horsepower, or the BTU per hour, or watt, and in terms of kilowatt. In the metric or international system, the corresponding units are joule per second, or in terms of calorie per second. It can be also in terms of watt and kilowatt. In physical terms, power is also the rate at which fuel or energy is used. Thus, power can also be expressed as gallons, or in terms of liters of oil per hour. Cubic feet, or in cubic meters of gas per minute, and tons of coal per day. Energy in electric circuits. Since energy is equal to power times time, the amount of energy used is directly proportional to the power of the system and to the length of time it is in operation. Since power is expressed in watts or kilowatts and time in hours or seconds and minutes are too small for our use. We have 4 units of energy, watt hour or kilowatt hours. Obviously, 1 watt is hours equal 1 watt of power in use for 1 hour, and 1 kilowatt hour equals 1 kilowatt in use for 1 hour. Example, find the daily energy consumption of the appliances listed if they are used daily for the amount of time shown. Toaster, so it consumes 1340 watts in 15 minutes. Percolator, it consumes 500 watts for 2 hours. Fryer, it consumes 1560 watts in a half hour. Iron, it consumes 1400 watts in a half hour. If the average cost of energy is 0.08 per kilowatt hour, find the daily operating cost. Solution for the toaster, 1340 watt is equivalent to 1.34 times 1/4 hour is equivalent to 0.335 kilowatt hour. Percolator, 500 watts equals to 0.5 kilowatt hour times 2 hour is equivalent to 1 kilowatt hour. Fryer, 1560 watt is equivalent to 1.56 kilowatt times half an hour is equivalent to 0.78 kilowatt hour. Iron, 1400 watt is equivalent to 1.4 kilowatt hour times half hour is equivalent to 0.70 kilowatt hour. We need to sum up the total. It is equal to 2.815 kilowatt hour. The cost is 2.815 kilowatt hour times 0.08 pesos per kilowatt hour. So we have 0.225 or approximately 25 or 23 cents. Clearly, the power being used at any specific time during the day by a residential household varies considerably. Example, it has been estimated that the average power demand of a household is 1.20 kilowatt. Calculate the monthly electric bill of such a household, assuming that a flat rate of 0.08 per kilowatt hour. Solution, monthly energy consumption is equivalent to 1.20 kilowatt times 24 hours per day times 30 days in a month is equivalent to 864 kilowatt hour. The electric power bill is equivalent to 864 kilowatt hour times 0.08 per kilowatt hour. So you are charged of 69.12 pesos. Power is the rate at which energy is used, the rate at which work is done. Under the English unit system, the unit of power is expressed in horsepower. The British thermal unit per hour, watt, and kilowatt. Under the metric system of Standard International, it is expressed in joules per second. Calorie per second, watts, and kilowatt in physical terms. Power is also the rate at which fuel or energy is used and expressed as liters of fuel per hours. Cubic meter of gas per minute or tons of coal per day. Power in electric circuits. The unit of electric power is watt, or it is abbreviated as W. A larger unit of 1000 watts is the kilowatt, or abbreviated by capital K and small letter W. The power input in watts to any electrical device having a resistance R and in which the current is expressed in capital I is given by the equation W equals to I raised to the second power multiplied by R. Or simply we can use this formula as W equals to I times I multiplied R, where W is wattage. It is true for both DC and AC circuits. However, since the resistance of an item is generally not known, but the circuit voltage and current are known, it would be preferable to be able to calculate power using these two quantities. This can be done, but is different for DC and AC. In DC circuits, by Ohm's law, V equals to I times R. And since W is equivalent to I times IR, so to simplify it, W is equivalent to V times I, where W is in watts, R is in ohms, and I in amperes, and V in volts. In a alternating current circuits, impedance is comprised of resistance and reactance. AC resistance of inductance and capacitance and causes a phase difference between voltage and current. This phase difference is represented by an angle, the cosine at which is called the power factor, abbreviated as PF. This quantity is extremely important in that it enables us to calculate power in an AC circuit. The AC power equation is similar to that for DC with the addition of this special AC term of power factor, that is W equals to V times I times PF.